Mathematics is about learning and how you learn and how anyone can learn anything and how it's all interconnected. And in order to do that, you first have to be able to distinguish between things. So, for example, as soon as I notice that this circle here, which is a zero, as soon as I notice that it's different than anything else, whether it's the one, the comma, the rest of the page, whatever it might be, I am then able to talk about that specific thing. Now, in this particular case, if I apply this to real life and I say I have zero of something, that doesn't really have any meaning. But if I say I have one of something, then I need to be able, as soon as I notice that there's one of something, I automatically infer that there is a zero because one of something has to be distinguished from not having that one of something. And not having that one of something would be the same as having zero of it. So for example, if I have one marker here, as opposed to not having a marker, it would be like having zero markers. So in order to notice one single thing, you automatically bring into existence here two symbols. And these two symbols, the 0 and 1, that then creates the foundation that you can build on. So as soon as you notice one single thing, you are now able to talk about two items, a 0 and a 1. And then I can begin to string these together. So for example, you do something that is called counting. You count. So in order to do mathematics, you do have to have the ability to notice things, and then you have to have the ability to continue noticing. So continue that by counting. Now, in base 10, we have 10 different symbols. We have 10 symbols here. From this circly looking thing, a line, more of a squiggle, even more of a squiggle, some constructed lines, some lines combined with a squiggle, a more circular bended curve motion, some more lines, a connected circular and bent kind of motion, and then an upside down version of this motion. So, right, these are our symbols. These are what we can then use to discuss or count things, whatever it is, as long as you're able to notice it. As long as it's something that you can notice, you're okay. And then you can assign these symbols to those particular, however many values it is that you've noticed, however much there happens to be. You can notice it, and you can assign one of these symbols to it. The only other thing to do at that point is to recognize that this 1 and this 0 are different. And then to move on to 2, all I need is 2 of these that came before it. And to move on to the next one, I just keep adding whatever it was that had come before it. Right? To get to 3, I add the 2 and the 1. To get to 4, I add the 3 and the 1. To get to 5, I add the 4 and the 1. Right? You just keep adding 1 to everything, and that gives you the ability to count. Now, to then represent anything further than that, to figure out, well, what comes after a 9, you then throw down one of these, and then you add to it a placeholder. So what we've done is we said we've moved past this number of symbols, and now we're going to start combining combinations of these symbols. So I'm going to instead of having just a 0 in front of all of these, instead of having a 0 in front of them all, I'm going to have a 1 in front of them all. So I'm going to go 1 0, 1 1, 1 2, 1 3, 1 4, all the way up to 1 9. And then after that, I'm going to go 2 0, 2 1, 2 2, 2 3. And I can do that now for as many as I need, an infinite number of possibilities here. I now have all the possible positive numbers that I can have. This also, in order to count this far, we relied on a property known as addition. The property of addition allowed us to say, well, what is 2 combined with a 1? Now, why do we suppose that we can use this operation? Why should we be allowed to use that operation? Well, if you just look around you in real life, if you happen to have a half a glass of water plus another half a glass of water, in real life, you can combine things. You can actually take a half a glass of water and pour it into another half a glass of water, and you will have combined. You will have added those things together. And that then allows you to do that with other things as well. It doesn't have to be water. Maybe you could add, some piles of dirt, right? And you could keep adding to that pile of dirt until you get a really big pile of dirt. And you could add the number of apples that you have, the number of things. That number is a placeholder, and it's representing the value of the apples, right? It's not necessarily representing a weight, but it's representing a count, right? A specific counted item, or in this particular case, the numbers themselves are just keeping a count of things that you can notice. So whatever you can notice, you can count it. And if you can count it, you should be able to add it, because we have this property of being able to take things we can notice and combine them together. So if we can do that, we can then add. So far, we have two things that we can do based off of simply noticing something. So for example, your computer can actually do some really complicated operations. And you might notice that you could, make a calculator tell you how much, two numbers multiplied together are. Let's say 4 times 5. And your calculator just spits out, well, it's 20. Your calculator is actually saying 1 plus 1 plus 1 plus 1, which is 4, and then repeat that 5 times. Once your calculator has done this, and pardon the double addition here, but once it has taken 1 plus 1 plus 1 plus 1, which is 4, and then it repeats that process 5 times, it gets a final number, which is 20. And so it is then representing that with the number 20. That's how a calculator or computer would do multiplication. We, however, have come up with some quicker shortcuts. As long as you memorize a table, a multiplication table, there are some quicker ways to do these things. But ultimately, that is the nested idea. That is exactly what is going on when you multiply 4 times 5. It's just that you're not actually thinking out these steps. You've probably gotten so used to doing it that you're just able to recall what exactly that number happens to be. 4 times 5, well, that's 20. So this is the beginnings of mathematics. You're able to notice things, you're able to count, and then you're able to add.